there's two of each type, so I'll kind of review the first one with you, which is pretty fresh because it's conics, and you just did your corrections on that. And then I'll leave the other one for you to work on. So in number 1, consider the conic described by the equation. And this happened on your test, something like this. It didn't tell you whether it was a hyperbola or an ellipse. But how can you tell? Which one would that be here? So what would this be? What's the sign in between that you're looking at? You're right. You have your cheat sheet. It's the sign in between the x squared and y squared. So in an ellipse, it's x squared plus y squared. In a hyperbola, it's either x squared minus y squared or y squared minus x squared. So not that this is ready to go yet, but you can already see it's a positive 36x squared and it's a positive 4y squared. Because they're both positive, I already know it's an ellipse. Do you follow? Okay. So just have that in mind and rearrange it accordingly. So I'm going to go down here where I actually have space. 36x squared will still come first. What comes second? Minus 288x, followed by 4y squared, good. Followed by 40y. And then what? Well, I've got these 4 terms I've already brought down and rearranged. But the 532 needs to be brought over. Good. Subtract it over so it equals negative 532. And then we're going to try to complete the square and turn it into the right format. But before we can complete the square, what do we have to do? Factor out the 36 off the x's, which will leave me with x squared minus 288 divided by 36. 8. Leave a gap there. Off of the 4, or off of the y squared, take out a 4. Leave a little gap there. Okay, so what am I adding in here? Positive 16. And so to counter that, what am I doing to the right-hand side? Right. I added 16 in a set of parentheses that's being multiplied by 36. So even though I only wrote plus 16, I technically have added 576 to the left, because that's what 36 times 16 would distribute to. So if I've added 576 to the left, I have to add 576 to the right. And then what am I adding in this set of parentheses here? 25. So I've written 25, but I actually added 100. So I have to add 100 over here. So completing the square, completing those trinomials makes them factorable. The first one is x minus 4 squared. The next one is y plus 5 squared equals some number, negative 530. What is it? 144. And then regardless of hyperbola or parabola, they always need to equal, no, I said that wrong. Regardless of hyperbola or ellipse, they need to equal 1. So I need to divide everything by 144, which is really just going to mess with my coefficients. 36 over 144 is going to reduce to 1/4. So x minus 4 squared over 4. And 4 over 144 is going to reduce to 1 over 36. Okay, so where is my center beam? 4, negative 5 is in what quadrant, just so I can use my graph wisely? which quadrant? So here's first, second, third, fourth. Fourth quadrant, right. So when I set this up, I'm just going to give myself mostly a fourth quadrant. Doesn't mean the whole graph is going to be in there, but at least you know the graph is centered there, so you might as well give yourself more of it to work with. And you might do that and then not have enough room and have to start over, which is just annoying. But 1, 2, 3, 4, negative 1, 2, 3, 4, 5. So here's your center. So change this equation to standard form. Part A is done. We're not ready for the length of the major axis yet. Okay, so this has been pulled how? Who can summarize? Go ahead, Ryan. 2 units. 2 units in the x direction, 2 units horizontally. Good. So there's a point on our ellipse, and there's a point on our ellipse. And then what'd you say? 6 up and 6 down from the center. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And that's your ellipse. Good. So how long is the major axis? 12, right? It's the long way across the parabola. That's 12 units. So we graphed it already. Labeling the coordinates of your vertices is just 1, 2, 3, 4, 1. 5, 6, negative 5. 4, negative 11. And 2, negative 5. They didn't ask us for this, but they could, so I'm just going to go over it. What is the value of A here? 6. In an ellipse, A is always the bigger number. In a hyperbola, A always comes from the first number. Do you see the difference? So look at my 2. A always is the bigger one. If it's stretched horizontally, A is under your X. If it's stretched vertically, A is under your Y. A is always the bigger one in an ellipse. In a hyperbola, A just always comes first, regardless of whether the hyperbola opens up or down. Okay, and that's a difference that got confusing. So A equals 6, B equals 2, and if you needed to find the focal points are always along the major axis. So they're going to be somewhere up in here and down in here. You find C with the equation A squared equals B squared plus C squared. And that equation also changes for hyperbolas. So I would use A and B to find C. C is always the distance between the center and the focal point. So I would go up C and down C to find my focal points, if it asked me to, which it could. Okay? All right. Over to 3. This is a hyperbola, kind of showing us that. And I know it because of that subtraction sign. Ryan talked about that earlier. So if it's addition, we're thinking ellipse, subtraction, hyperbola. Again, they always need to equal 1. So I have to divide by 16. This one doesn't have any completing of the square. So we have x squared over 4 minus y squared over 16 equals 1. So just out of curiosity, what is A here? 2. This is where on the test I lost some people because people put the bigger one first, so they would bring the negative term out in front. Does that make sense? You never want it to lead with a negative. People were bringing like the negative y squared over 16 out in front. Hyperbolas, you just don't want that. You still want it to lead with a positive and then subtract the other. But A is 2 and B is 4. and we could find C if we needed. The other thing is, which direction does this open? And this is, again, where I think people got lost because they moved their negative term to the front. But the first term, which should always be positive, dictates the direction of opening. So if it's leading with an X, it's opening left-right along the x-axis. Versus if it was a y squared minus an x squared, the y squared leading it would dictate that it opens up and down. Yes? So we know it opens left and right. It doesn't open to the bigger number like an ellipse does. So there's your difference there. So where's the center? 0, 0. And then the whole stretching concept that ellipses follow, so do hyperbolas in a way. It just is how your rectangle stretches to give you the proper asymptotes. So from 0, 0, I stretch how? Val. 2 units left and right. And that's not the stretch of the hyperbola per se, the way it is an ellipse, but it's going to give us kind of the outskirts of our rectangle. And what up and down, Val? Right. So that just kind of gives us that rectangle guide. And the diagonals that go through the center of the rectangle give you your asymptotes. Now, you could draw it up down, but it would be wrong, right? That's what's tricky with this. Like you could draw something there and there, but you'd actually have them flip-flopped if that was the case. And we said it from the beginning, since it starts with an X, here's your vertice, and it opens wide enough to make those diagonals asymptotes. And if they asked us to find focal points, they're in here somewhere. So whatever C value we get, we would go from the center to the right that many C units, and from the center to the left that many C units. This is still our major axis, and that's confusing because it's not the longer way across, right? But the major axis is what connects the vertices. So even though it's shorter than the other way across your rectangle, this is your major axis. These are your vertices, 2, 0, and negative 2, 0. So they could ask you for your focal points. They could ask you for the length of your major axis, which would be 4. Your minor axis would be 8. And that's confusing because we want to think of our major axis as the longer one. And sometimes it will be, but not here. It's only the longer one for sure in an ellipse. Any questions on that? Good? All right. Try to draw a picture for 4 on your own. Alright, here's how my picture is going to be. Oh, there's a tower. That's my tower. There's a man on the street. His angle of elevation to the top is 29. Good? And definitely a right triangle. We're assuming this is not the Leaning Tower of Pisa and that the tower is perpendicular to the ground. Then after walking toward the tower, so here he is, towards the tower would be this direction, yes? For only 200 feet, so that length is only going to be 200 feet, then he's there. Now his angle of elevation is 65. Yes? What is the height of the tower to the nearest foot? So we're going to be looking for this length. Now, who remembers how we handled this? Right, you can't actually do SOHCAHTOA because in the one right triangle, you have the angle, but you don't have opposite, adjacent, or hypotenuse. Do you follow? And you would need at least one of those. In the bigger right triangle, you've got an angle, but again, you don't have the opposite. You have part of the adjacent, but not the full adjacent. And you don't have the hypotenuse. So SOHCAHTOA can't be used. We have to use, this is like law of sines, law of cosines. So first, let's review what those are. So you have A over the sine of A equals B over the sine of B. That's your law of sines. And your law of cosines is some side squared all by itself equals the other two sides squared, so A squared plus B squared, minus 2AB cosine of capital angle C. These two can be used in non-right triangles. In fact, you probably wouldn't use them in right triangles because you would use SOHCAHTOA in a right triangle if it was possible. So what this allows us to do is it allows us to work in this sliver of a triangle. That's definitely not a right triangle. And we can use it to find something in this triangle that would help us with this smaller triangle, right? So this sliver of a triangle and this triangle overlap by this piece. So if we can use this sliver of a triangle to find this piece, then we can use this piece in the 65-degree triangle. Do you follow? So it's a two-step process. We essentially want to find this x using the sliver of a triangle over to the left. So we're looking for x, and we have its opposite angle. So it would be x over sine 29 equals, and the only other side we have is the 200 over, what is the angle across from the 200? Right, we don't have it yet, but we can figure it out, yes? Because 65 and 115, is it? Have to make 180, and then 115, 29, and 36 would complete that angle. So sine of 36. So make sure your calculator is in degrees. Cross multiply 200 times the sine of 29 and then divide that by the sine of 36. Gives you x equals 164.9614781. Good? So I cross multiplied, got that product, and then divided it by sine of 36. So now going back to SOHCAHTOA, which is what Maddie initially said, if we're focusing on this triangle, we now know that length. And we're looking for T, the height of the tower, we'll say. So we have a 65-degree angle. We're looking for the opposite, and we already know the hypotenuse. So which one involves opposite and hypotenuse? Sine, cosine, or tangent? Guess again. Sine. Sine uses opposite and hypotenuse. So we'll take, in our right triangle, the sine of 65 equals the opposite, T, which we're looking for, over the hypotenuse, which used to be x, but we now know is 164.9614781. And to solve for T, what do I do to both sides? Or just multiply. Dividing by this, just multiply this away. So sine of 65 times that number. So on your calculator, to avoid rounding, sine of 65 times, and you can just scroll up and grab that number exactly. And we're supposed to round that tower height to the nearest foot, which would be what? 150. So law of sines, law of cosines. Some of you, I remember in this chapter, thought it might be easier to do the law of sines twice in these types of problems. So you'd still do the same first law of sines that we did. Then in your right triangle, just because you can use SOHCAHTOA doesn't mean you have to. You can do t over the sine of 65 equals that number that you found over the sine of 90. If you wanted to keep it law of sines twice, you can do that. It's just that most often when people see right triangles, they just use SOHCAHTOA. But you can do the law of sines twice if you want. Okay? All right. 5 is going to be a review. How about the force questions? These were fun. I thought we got better at these by the time we were done. Let me give you this back so I don't forget it. Okay. 2 forces of 17 and 39 act on a body at an angle of 142. So, that's an obtuse angle, huh? So, I'm going to let this be my 17 and this be my 39, a little bit longer. And the angle between them is 142. So, let me ask you this question. When these two angles, or these two forces are happening simultaneously, are they going to be helping each other or hurting each other? Hurting each other, right? So, what do you expect your resultant force to be? Do you expect it to be over 39? Somewhere in between, or less than 17? Okay, should be. Yeah. It's definitely not over 39 because they're not helping each other. Well, I was just thinking if something is pushing at 17 and something's pulling away from it, would that drag it down from 17? Because the differential is the magnitude between the two is too much. It's definitely not going to be over 39. We know that. All right. So how did we finish these pictures? Do you remember? We drew we drew a dotted couple lines to turn them into parallelograms. And I told you to make them dotted so we could differentiate what's the force versus what we're just kind of using so that we can capitalize on properties of parallelograms, which we used to have a beautiful thing on the whiteboard there, Mrs. Grisanti, jipping us. Used to have all of our properties up there. Let's see. So our resultant force is the diagonal, which does not cut the 142 in half, and that was tricky, right? Unless those forces were both 17 or both 39, we're not cutting that in half. It's cut, but not equally. What angle can we label if we know this one is 142? Right, one of the consecutive angles, so either this one or this one, depending on if you want to work in this triangle or this triangle. So 142 and this need to be supplement, so we're missing 38 right here. Okay? And then we can complete that triangle because it's a parallelogram. If this is 39, this is 39. And so our focus is really in this triangle. And anytime you have side angle side, it's a recipe for the law of cosines. Yes? So when I gave you the law of cosines, I said one of these sides stands by itself, right? It's this one. It's the one across from the angle that you know. So I'll call that C. C squared equals 17 squared plus 39 squared minus 2 times 17 times 39 cosine 38. that 38-degree angle has to be across from the side that's by itself in the formula. And because the variable we're solving for is pretty much already by itself, this is just type all this in and take the square root of it. So 17 squared plus 39 squared minus 2 times 17 times 39 times cosine 38. So c squared equals all of that. And then square root both sides. 27.66. So C equals 27.66. That's your force. And that was the question. So we can be done from there. Right, we'll say 28. So in between, that was right. Good? Law of sines, law of cosines, no. But we can do this. At the top of the paper, I can have you just write the three of them down, whatever formulas you need down. Law of sines, law of cosines. If there's any more that come up, I'll add that. And you can do them and get them checked off right away. If you get them wrong, you lose your point, but then I'll at least give you the right ones to proceed accurately so that things make sense. Because if you're not using the right formula, then all of these concepts of are these, is this resultant force going to, or it's not going to pan out. Good? Okay. The other thing that they could ask here is like, what is this angle? How did the 142 get split? They could say, what's the angle between the 17-pound force and the resultant force? In which case, you would need to figure out what that is. And if that's the case, we could have just used the law of sines, right? 39 over the sine of blank equals 17 over the sine of, oh no, we wouldn't be able to do that yet. We'd still have to find that. So we'd have to do this over the sine of 38 equals this over the sine of blank. And you'd solve, if they ask you that. That would be one additional step. Say it one more time. Oh yeah, that would even be quicker, because then you wouldn't need to find. Oh, you would still need that though, because you wouldn't know this one or this one. You see it? You still need one complete pair of opposite side, opposite angle. And if we hadn't already found that, we just wouldn't have an opposite side, opposite angle. We wouldn't have an opposite side, and so we would be missing that. So it is still a two-step process. Good? All right, so 7, 8, 9, those are all force questions. Let's go to 10, which is solving trig equations. So finding a solution to a trig equation. This is a trig equation that kind of doubles as a what kind of equation? Because you have a sine squared and a sine. Quadratic. So getting it equal to 0 is issue number 1. You have to recognize once it's a quadratic that that's a must. And then to solve quadratics, you would factor. So, what times what gives us 2 sine squared? Yes, 2 sine times sine. And then you have to figure out what gives you 2. So it's either 1 and 2 or 2 and 1, but the order matters here because the outer one is getting doubled. and the inner one is not. So if I put the 2 there, that'll make the outer 4 and the inner 1. And it needs to be a positive 3, so I'm going to make it a positive 4 on the outer, minus a 1 on the inner. And then we tee it up, right? So the first one tells us that the sine of x has to equal what? 1/2, okay? So let's just focus on this one for a second. We're looking for all of the answers between 0 and 360. So 1 full revolution. How many times is sine positive 1/2 in the first revolution? 2 in the first quadrant, and the second quadrant, sine is positive. All students take calculus, right? So in the first and the second, sine is positive. So I should have answers for x in the first quadrant and the second quadrant for this first piece. What's the reference angle? 30. So in the first quadrant, 30 degrees is 30 degrees. I'm going to write reference angle equals 30. In the second quadrant, what is the angle that has a reference of 30, Maya? 120 has a reference of 60. 150. So for your first quadrant, that's starting at 0 and opening up 30 degrees. And for your second quadrant, that's starting at 180 and backing it up 30 degrees. Do you follow? Your reference angle is always off that x-axis. And then in your second one, sine of x equals what? And this is a dream because sine and cosine can never be outside of 1 and -1, right? So that has no solutions, and those are your only 2 answers. And then jump to 12 because 12 uses cosecant. That's not going to be as enjoyable. If 10 was miserable, 12 is going to be very miserable, is what I mean by that. I just put a positive twist on it. It's not going to be as enjoyable. All right, so still it already equals 0, but it's cosecant, which is not a problem initially when we're factoring. So what times what gives us cosecant squared? Cosecant theta, cosecant theta. And then how are we going to make the -8 happen with the -7? -8 plus 1. Good. So when I tee this first one up, what does cosecant equal? 8. Okay, now here's where we have to adjust for the cosecant. If cosecant is 8, what equals 1/8? Sine, very good. Got to know your reciprocal functions. And if the sine is 1/8, it's not something we have memorized, yes? But we are still going to have 2 answers because sine is positive in the first rotation, and we're only looking for answers from 0 to 360. Sine is still positive in the first quadrant and the second quadrant. We still need to find those 2 answers. Theta equals. Good? So what do I type in on my calculator? Inverse sine of 1/8. And inverse sine is only going to give us answers between -90 and 90, right? Remember how inverse sines and inverse tangents only give you 1 answer? This is essentially just going to give us enough to figure out the reference angle. And the reference angle is, does it say nearest degree? Yeah. Reference angle, 7 degrees. Are we good with that? So your reference equals 7 degrees. So what is the first quadrant version of 7 degrees? 7 degrees. And what's the second quadrant's version of 7 degrees? 173. Good. On the flip side, on the other teeing it up, what should cosecant equal? -1, which means sine needs to equal what? Say it again. Still negative 1. Not the opposite reciprocal here. Don't confuse it with perpendicular line slopes. Just the reciprocal. And so when is sine negative 1? So I don't know how, if you guys want to use your calculator. Like, I wouldn't use my calculator. I would think that sine of 0 starts at 0 and increases up to 1. And then it goes back down to 0. And then it goes to negative 1. So I would just know it's 270. But your calculator is certainly not going to give you 270. If I do inverse sine of negative 1, do you know what your calculator is going to give you without me doing it? It's going to give you negative 90. Inverse sine of 270. Oh. I didn't mean that. I meant inverse sine of negative 1. It's going to give you negative 90, which is the same thing as 270. So remember, inverse sine has to give you something between negative 90 and 90 on your calculator. Negative 90 is going to correlate to positive 270 going the positive way, because your answer has to be between. So it is a reference angle of 90. It's just after you go around. Is it time to go? Look at that. So your homework is to finish this sheet. And those are really your 3 topics. And then tomorrow we'll do some practice on some multiple choice ones, again, hitting up these topics.